pass in a string, and then if that string can be passed into an integer, then the try pass method returns true, and then you have an out parameter that actually contains the passed integer. And we can do the same thing here with the read method. So instead of calling it read, we'll need to change the name and the signature of the read method into try read. And not only do we need to change the name, but we also need to change the return type and the argument list. So the try read method now returns a Boolean that indicates whether or not the operation is actually possible. And then there's this out message argument that contains the value if the operation succeeded. So just like before, we can attempt to get the path from the ID and then attempt to see whether the file actually exists or not. If it doesn't exist, the method returns false. Otherwise, it will read the text from the file and assign the out parameter to the contents of that file and then return true. So with this try read method, there's no reason to have the exists method anymore, and we can just delete the exist method. And a client using this new API might look something like this. So it can, in an atomic operation, invoke the try read method, the ID of 49, and an out parameter of the type string. So if the ID of 49 has an associated message, the message out parameter will then be populated with that particular message, and the exists variable will be true. And if there's no message associated with the ID of 49, then the message variable will not be populated, and the exists variable will have the value false. And then you could explicitly add an if clause here that deals with the fact that what happens when exists is true, or what happens when exists is false. So this is thread safe, or at least it can be thread safe. So if you recall the implementation of the try read method as I've currently shown it to you, there's actually a race condition still left inside that implementation, but that's just an implementation detail, and it's actually something that you can deal with in such a way that there will be no race conditions in. So the problem is not that it's not thread safe, the problem is that this API is not particularly nice to work with. It's not very object-oriented. Particularly if you like to design fluent interfaces, every time you have one of these try read or try pass methods, you break the fluent method chain, because the try read method doesn't return the message, doesn't return the value that you're actually interested in, it returns a Boolean. So every time you have one of these things, you can't have a fluent interface. And whether or not a fluent interface is actually a good object-oriented design API is a different question, but it just demonstrates the sort of problem you run into when you design an API like this. So it's not particularly nice and object-oriented. And what object-oriented designers would typically tend to do, instead of using out parameters, is to say, well, if we have a method that returns something, but we also have out parameters, it's really an indication that instead of having various different primitive out values, we should probably introduce some sort of complex data type that can hold all of those values in a single object. So you could imagine that we introduce some sort of read result class that can hold both the exists variable and the message variable that you're looking at here. So I'm not going to show you that because it actually turns out to be a bad idea. And the problem is that if you imagine that you have such a read result object, it doesn't really solve the problem in the sense that you still need as a client to first start by looking at the exists property to figure out whether or not the operation succeeded. And then if the exists property is true, then you can start looking at the message property. But the message property there might be null if the exists property is false, so that leads you back to this whole problem of things being null and lots of defective coding. So that way of designing a complex data type that indicates success or failure turns out to be a bad idea. But the overall concept of introducing a complex return type that indicates whether or not this operation succeeded or failed is not such a bad idea after all. We just need to think about it a little bit different. And that's the next and final strategy that I'm going to show you, which I think is the best one. The third and, in my opinion, best way to deal with the problem of identifying whether or not a given operation is legal to invoke is a maybe. A maybe is a concept that we've borrowed from functional programming. If, for example, we've looked a little bit at F#, you'll notice that there's no such thing as a maybe per se, but there's something called an option type, which is the same thing. But in general, the concept is called a maybe. And a maybe is easy to understand because it's just a list or a collection with a very specific constraint. It has the specific constraint that it's a collection with either 0 or 1 elements inside of it. And that's it. A collection with 0 or 1 elements. I'll show you what that looks like in terms of the file store class. So I've brought back the implementation of the read method to the previous example, so there's no longer a try read method, there's just this read method. And you'd like to refactor the signature of the read method so that it clearly communicates that the return value may be there, but it also may not be there. And you don't want to return null, because null is tainted, because everything could be null. As an intermediary step, you could change the method so that instead of returning string, it returns IEnumerable string. So this is not where you want to end up, this is just an intermediary step in order to show you what's going on. The implementation still checks whether or not the file exists. And if it doesn't exist, it now returns an empty string array. On the other hand, if the path exists, it still reads the message from that file, and then it returns a new array with that message as the single element. So it either returns an array with 0 elements or an array with 1 element. So this sort of gets us there in the sense that this is the implementation that we are aiming for. But the problem is that if we just look at the method signature itself, the method is being too vague in terms of the guarantees that it provides to the client programmer. The client programmer that looks at the read method will only be able to infer that the read method somehow returns a sequence of strings. And that sequence may be empty, which is okay, that's part of what we want to say, and it also might contain a single element, which is also okay. But this method signature also indicates that it might return a sequence with 10 elements, or it might even return a sequence that stops. It's totally possible to implement IEnumerable of t in such a way that the sequence never stops. This is called a generator, which can be very useful, but in this case it's not all what we're trying to say here. So keep in mind when we talk about Postle's law, we learned that the stronger a guarantee that you can give the client programmer, the easier your API will be to consume. And right now, IEnumerable of string is not as strong a guarantee as you could provide. So instead of just saying it can be any sequence of strings, what you really want to say is it can be a very constrained collection of strings that will have either 0 or 1 element. Such a class, unfortunately, does not exist in the normal libraries that we use, but it's trivial to introduce such a class yourself. So you can create maybe a T class like this. And as you can tell, it implements IEnumerable of T, but basically what it does is it has two constructor overloads. It has a perimeterless constructor that assigns the internal collection of values to its array. And then it has another constructor that takes a single element of type T and creates an array with that single element in it and assigns that to the internal value field. And these are the only two structures that make the T contains. So it's only possible to create a maybe T that includes 0 elements or 1 element. Now, for simplicity's sake, I didn't include a guard clause in the constructor that takes a value of input, but you could imagine that we add such a null guard clause there as well in order to take the maybe part from the null integer. That's it. Apart from that, the maybe of T class also implements IEnumerable itself. It just does that by delegating to this value. So that's good. So maybe of T, once you understand what a maybe of T is, you know that it's correct and that it contains either 0 or 1. So now you can change the file store read method to return a maybe string. And it's the same thing that goes on. If the file exists, you return a new maybe of string, and invoke the constructor that takes no argument. Otherwise, you need to mess with the file and then you return a maybe of string. And any client programmer that now sees your read method will understand, because time taken on that over 2 years, that this effect may or may not be true. And you could argue that time programs are not related to time, but on the other hand, that's just 1 year time. Now, 1.7 million is 2 years, even if the crucial aspect of this movement is that now you can distinguish it's really easier to compare it with the final method. Both of those methods guarantee that they will return a value of the return type that the method is, and they will not return. This time they will not return long term, and the these methods will not return an all return type. But it will return a return, let's say it may be anything. That's how time is specific. So that any time stone of this final. And usually we say, well, time is also a good mind we talk to people and people. The people don't see the symbol that will provide you with value between this is not something that we have. This is only part of the concept of nature. We also say that this is singular. Although singular still is just not one thing. We know it. I wasn't really know, but if it's true, guaranteed. And if I wanted to detect whether or not the nine necessary is the first declaration but there I will start to investigate it's much more closely approach to the problem which what happens to the reality structure. To summarize, encapsulation is all about making the whole other time programs, including the certain feature to be a process structure. We start out by giving a discussion of which one is not this but the problem is how do we think what's wrong with it? What constitutes the use in terms of how to refer what is good situation of itself. This is really the same thing, children usually like before we my part the refactor console changes to I so that the console is actually easy for the I and the period of the full computation is it is also very clear that the change method will be more useful to approach the change method you can also see that the transfer structure is from this different and you can also this view of this mostly appear not any significant what methods need to be integrated as ratios of value of the function. So that's one of the things to drive the strict form with the clear form. And we have to keep in mind that we have to be value. Because the notion of the of the perceived of has to be very limited to the creator. Everything else is just being used in the process of final movement. Now this is very important, but strong enough for you. It always reminds me of the parallel in two aspects. But you could ask yourself in a two world, world. Most world is either that the time control the downside positive and electronic alarm system surrounding the program. And by the way, computer is not only network and control. There is a great deal of activity in concept of the use. These things is conceptually more effective to the the other is to integrate everything, not just the loss of programming skills. But again, if you think of the analogy to realize that we have this concept of the then you get to the theory of application, the other execution, and still difficult to use the lines because there are certainly associated and so on. And this is because of the investigation. Because they make classes, the focus is with the learning. There is great probability particular learning still has to be focused. In the end, the idea is to write for sticky programs or individual programs so that you don't know what you need when you go for class. And it's difficult to do this if you don't have this experience. So this course, I've tried to teach you the topic simply through the solution of the The other part is to make the person some of the targets. If it's understandable for targets to apply, you need to require the research and you free up time for other designers to get that work. You also learn about this concept of the class because if you can at all strategically design a class in such a way that the type system will take habit in that direction. But even if that's not possible, at least fail a class possible. And when you fail a class, you provide for a good suggestion. But not only tell the actor on that in the right way what is wrong, but also what you need to do about it. One of the most important features of translation is to make the dynamic space as possible as possible to be difficult to create as possible, so that you almost have to work success that if it compiles it to work. Notice that no, not that no itself is a false function, but the problem is that the programming platforms nowadays, all objects can be known. And since everything can be known, there's already a change in the fact that it's knowledge. Because almost all types are known by people. And you can't change them because they don't think that's what they want to do. Instead of using no, just agree with the theme that no is never a value in knowledge. So if you need to deal with the concept of the value not being present, then maybe a secret is not better way to model. So one of the concrete techniques that we learned about in order to make the proof better and more calculated is what is more, be as conservative about the output as possible. Give as many guarantees about the output as possible, but do try to be as tolerant of input as possible. And the other technique we learned about was command query situation that says design your operations in such a way that an operation is either a command that assigns it or a query that is translation but assigns it. That enables you to write for the programmer, or at least for programmers that doesn't know as much as you need the problem of Hello, my name is Mark, and this is the first module out of 5 about solid. Now ask yourself, do you want to write solid code? Usually, when I ask audiences this question, most hands go up because people want to write solid code. And then when I ask them, why do you want to write solid code? What do you think it means? The answers are more vague. Solid code sounds good. It simply sounds like a desirable quality of software to have. And it is, but it probably doesn't mean what you think it means. Now, if you think about the word solid, it's a property that matter can have. So matter can be either solid, or fluid, or gaseous, or in plasma form. And lots of different materials can be in solid form. You may also think about the word solid in the sense that it almost sounds like something is unbreakable, which this image tends to indicate is not always the case. So glass is actually solid. Despite a meme going around that it's actually very flowing fluid, it actually is solid. And as you probably know, glass tends to break quite easily. So solids can be brittle. And that's not what we are aiming for when we write software. What we really aim for when we're talking about solid code is solid code that's pliable, code that you can shape into different forms, and where you can change the shape if it turns out that the original shape you had in mind doesn't really correctly address the problem at hand. This is very important because you almost never have all the requirements up front. Even if you think you have all the requirements up front for a piece of software that you're programming, requirements change as you go along. And the point of writing solid code is to make code so solid, so pliable, that when requirements change, you can also change the code to fit the new requirements. Now, before I tell you what solid is, I want to tell you what solid is not. And the reason for that is that, in my experience, you have to learn about concepts where you think you already know a lot about that concept. You may have misconceptions about this concept, and it's important to address those misconceptions so that you can combat those misconceptions as you try to learn the new things that you want to learn. So, I will tell you what solid is. Obviously, that's what I'm going to do in a couple of hours. But before I do that, I want to spend just 5 minutes talking about what is solid not. The solid is not a framework. The solid is not a library. So it's not a specific technology. This is both good and bad. It's good because it's not technology bound, which means that when you learn about solid, you can apply that knowledge that you gain to various different technologies. So you can take your knowledge about solid design and apply it to Java, or apply it to C# code, or apply it to C++ code, or whatever else object-oriented code you will encounter throughout your career. So that's the good thing about solid not being technology bound. The disadvantage is that it's a little bit more fluffy in the sense that it's more difficult to explain in concrete terms. I will give you lots of concrete examples, but there's not a concrete thing that you can measure and say, well, this is so and so much solid. Because it's not technology bound, and it's not even a pattern. It's more fluffy than even a pattern. Another important point about solid is that solid is not gold. Solid is not gold because you can't measure the degree of solidness of a code base. And it may seem a little bit contradictory, but it's not particularly hard to walk up to a code base and start pointing at that code base and say, well, this is not solid, or this is not solid, or this is not solid, because it takes business principles. So in a sense, you say it's possible to measure to a certain degree that a code base is not solid. But then when you try to make it solid, there are lots of different ways that you can approach solidness in a code base. And I think solid is something that you can approach asymptotically. You'll never really reach the goal that you just get closer and closer to. But you can always discuss in a given code base if you could make it even more solid, or you could make it solid in a different way. So don't try to make it a goal, because it's not always going to be to your advantage if you try to make solid goal. First of all, because you can't measure it, but also because solid is not necessarily the answer to any solid question. I'll get back to this in a minute, but solid is a reaction to a set of very specific code points. And it seems to be very advantageous and helpful when it comes to addressing those particular code points. But if your code has other problems, there may be other answers that are solid. But what I can tell you though is that solid code is going to be different. Most code bases today, even though they are written in object-oriented languages, tend to be not object-oriented but actually more procedural-oriented. Solid is also known as the principles of object-oriented design. And when you apply those principles, the sort of code you arrive at is much different from the procedural style that most code bases actually have. So writing in an object-oriented language in itself is not a guarantee that your code will be object-oriented. But if you apply the solid principles, then you start pulling your code towards a more object-oriented design. Another reason why I'm telling you this is that it's a very natural reaction when you encounter something that is different from what you're used to reject the new thing that's different. And you need to combat that natural tendency when you learn about solid, because it is going to be different than the code that you most likely encounter on most cases. The purpose of solid is to make it more productive by making the code more maintainable. This is just like encapsulation. This time, the focus is on decomposition and decoupling. As I told you before, solid is a reaction to a set of design skills. So if the code suffers from one or more of those design skills, then it makes sense to try to apply solid principles. You might have other problems, or you might not, but then solid may not be the best answer. Maybe there's another answer that will address your problem. But the problems or the design skills solid tends to address are the following. The first one is called rigidity, which means that the design is difficult to change. And this has much to do with the suppleness that I talked about before, where you get a new requirement. And if you have a rigid design, it means that even though your design is good, or it seems like it's a beautiful design, when you get a new requirement, it's very difficult to meet that new requirement because this is rigid. Another design skill is fragility, which means that the design is easy to break. So you may have a very beautiful software architecture, but then if you ask a developer who's not familiar with that particular design to work in your code base, then things start falling apart. The third design skill is immobility, which means that the design is difficult to reuse. And there's another meme going around at the moment that reuse is overrated. And I don't really want to go into that discussion now, but being able to use a code base or part of the code base is sometimes very desirable. So if you can't do that, you may have a problem. The fourth design skill is viscosity, which means that it's difficult to do the right thing. And the final one isn't perhaps the most interesting. It's meets its purpose. Over design. This is something that we as programmers have a strong tendency to do over and over again. Sometimes we also call it gold plating. This tendency we have to think that we could actually make this code that we're running at the moment a general purpose library, and then we will be able to blah 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 blah, and we start to dream up all sorts of strange things we could do that we probably never need. But I need to discuss the spell of over-designing a bit more, because a very common reaction to seeing refactoring solid principles is to think that solid was much more over-designed and much more needless complex than the alternative. And the main reason for this is that what we are really trying to do with solid design is to address complexity in software. But the problem is that when you try to learn about how do you deal with text in software, what you really should do is to look at a very, very complicated and complex piece of software. But you've probably seen code bases like that, and it takes weeks or even months to learn about how those code bases actually work and how all the code is typed. And you can't learn about things if it takes weeks or months to actually understand the code base, what it looks like before you do the refactor. So we need to come up with examples that are toy examples, which are too simple to actually seem to warrant the refactor we do in order to apply the solid principle. So you have to keep in mind when you see all the example code that I'm going to show you with the powers, that the code is a stand-in for something that is much more complex than what you're going to see on the screen. So I'll try to point it out as I go along, but keep in mind that your code is probably much more complex than the code that I'm going to show you. And that's when solid really shines. And it may seem a little bit overcomplicated to apply solid principles to something that's not particularly complex. But that's just how it works when you need to learn about something through examples, and we can't really make the examples too complex because we think we can learn. SOLID is an acronym. The S stands for the Single Responsibility Principle, which states that every class should have a single responsibility. And exactly what that means I'll get back to later. Right now I'm just giving you an overview of those principles. The O stands for the Open Close Principle, which states that a class should be open for extensibility but closed for modification. The L is the Liskov substitution principle, which states how polymorphism should work. Not necessarily how it actually works, but how it should work. The I is the interface negation principle, which describes how interfaces should be designed. And finally, the D is the dependency inversion principle, which describes the relationship between abstractions and types. Now, since this is programming terminology, each of those principles in themselves obviously have three-letter acronyms. So the single responsibility principle is the SRP, and the open close principle is the OCP, and so on. Another important point to be aware of is that there is no built-in order to those principles. Just because a single responsibility principle is mentioned before the open close principle and so on, it doesn't mean that it's the most important or the least important principle just because it appears first. The reason why it appears first is just because SOLID is a nice acronym. But when Robert D. Martin, or Uncle Bob as is also known, originally described these principles, he started out by describing 3 of those 5 principles, and then later on added the 2 other principles. And he didn't have them in that order, so they didn't really spell anything in particular. And then later on, a colleague of his pointed out that if you reorder the principles, they would actually become solid. So the order is not important at all. And another thing that's important to realize is that not only is the order not particularly important, but there's a strong relationship between each of those principles. If you take each of these principles in isolation and try to apply them to the code base, you will get limited benefit out of that. It's only when you take the entire package and apply it in its entirety that it starts really making sense and giving you lots of benefits. So if you have a code base where you want to refactor it towards a more solid state, if you will, it doesn't make a lot of sense to say, well, in this week we'll start by applying the single responsibility principle, and then next week then we will apply the open close principle and so on. That could lead you to a strange place where the benefit is limited, or it might even make it worse. A better approach would be to take a tiny part of your code base and say, in this week, we will apply all 5 principles to this particular part of the code base. And that will make that part of the code base solid or more solid than before. And then you can move on to integrations and apply all 5 principles to other parts of the code base. So there's a strong synergy effect between those 5 principles. So it really makes sense to think about them in isolation. When you are going to learn about these principles in the next couple of hours, obviously you'll have to learn about one principle at a time. So we will look at each of these principles in isolation. But when you apply them in real code bases, then think about all of them, or many of them that make sense in a given time. This is just one. Just like in the previous module of encapsulation, the sample code will be the file store class. But before I start refactoring this example code into solid code, I want to make a few changes to it in order to enhance some of the built-in problems that there might be in this design. So first of all, we could actually strengthen the guarantees about how this file store class works by changing the working directory and the files from strings into proper objects, which would be a good idea to do right away. So instead of having a working directory and file names represented as strings, I'll refactor this particular API to use directory info and file info. And I also changed the name of the last method from get file name to get file info, and also this change. These are the changes on the API level, but on the implementation level, I've also changed the code to make it more enterprising. As you can tell, I've added more lines of code to the save and read methods. Each of those methods now do some logging, and they also do some caching, as well as doing what they did before. So in this case, logging seems to be mostly for the sake of the developer because it logs information and debug information, probably in order to help the developer figure out what's going on in the system. But this could also be logging operators, or it might even be logging of business transaction that could be extracted into further business transaction. So there's some logging going on, and this is a very common thing to do in real production systems. Another behavior that's being added here is caching. So the caching is the fourth line of the save method where it goes list of cache at all objects, and also in the read method towards the end you can see that it says bar message equals list of cache of get or add. It's kind of a funky API for caching at the moment, but there's a reason why it's currently looking like this, and maybe you already recognize this particular API, but I'll get back to this in a moment. So these are not at all uncommon additions to code. I've seen lots of code looking like this. And again, you have to keep in mind that this is just a placeholder or a stand-in for code that might be a lot more complicated than what we're looking at here. Code that might not fit on a simple screen where you have to scroll and scroll and scroll in order to see all of it. One of the problems with code like this is that although it's necessary to do logging and to do caching,